All right. So continuing our discussion on brief overview of Java, let's talk about the types in Java. So primitive types, there are 8 of them. Int for integers, double for real numbers, char for characters, ASCII and Unicode, Boolean for the true and false values. And then these 4 are the more commonly used ones. There are 4 others. There is a float, wide, short, and long, similar to several other languages in the C++ family. These are all built-in types, as in the types are implemented in the language, and these are not objects. Even though Java is an object-oriented language, these types, primitive types, are not objects. This is an important difference, and also, a thorn in the scheme of things in Java. We'll talk a little later how Java implementers have tried to overcome the problems due to this being not a type a little later. And so these primitive types can be manipulated using operators like plus, minus, and greater than, and equals, and so on. There are several others. I have listed only a few. Primitive types can be contrasted with what's called the reference types or objects. They are defined using the keyword class, and typically a class would have data as well as behavior. Um, Data are called fields and behaviors are called methods. You can call methods on a class object, and you can give values for its fields. Um, One popular example of built-in reference types is string. Like again, like many other languages, it's a character string you can use for creating words or sentences, and names and such things. In addition to the built-in types, a user can extend the language by defining their own classes. So when you are creating your own class, let's say a student or a vehicle, or some game object like a playing card, you are essentially extending the language because you're introducing a new type. You create objects of that type, and depending on the language implementation, language design and implementation, the objects you create follow the type rules of the language. Okay? In case of Java, it's a statically typed language, and what that means is when you create an object, you create a class, let's say student, um, give it a method, let's say enroll. A statically typed language like Java would check whether when you're calling the method enroll on an object, if the method is defined in the class at compile time. If it's declared rather instead of defined at compile time. If it's not, you'll get an error. So that's how you're creating types and extending languages. One point to note is reference types, variables of reference types to be more precise, unless initialized, you cannot call methods on them. If you try calling methods, you'll get null pointer exceptions. So that is something you should be careful about. Yeah. Here is an example of a reference type or a class. So here we are creating a public class animal, and giving it 2 fields, a string name and an integer number of legs. There could be other fields, but for now we are concerned with these 2 only. Before proceeding, let's talk about some important things here. So first of all, private and public, 2 keywords were introduced. As you can imagine, public is anything that is accessible to other parts of the program outside this particular file or class. And private, in case of Java, and again in many other object-oriented languages, specifies that this particular field or a method cannot be accessed from other classes outside of this class. There are, of course, other levels of access control, but for now, it should be good enough to start with these. And I would urge, if you are not familiar with other access controls in Java, um, refer a book or some online documentation. But these two should take you through many parts of this course, largely. Yeah, the next part here is a constructor. Um, constructor Constructors are special methods that basically build the object by populating most, if not all, fields of that class. In Java, a constructor is a method that has the same name as the name of the class, and it can have any number of parameters, including 0. Here we are creating a public constructor which takes a string and an integer. The string becomes the name and the integer becomes the number of legs for the created object of that animal type. So another thing is the this keyword here, this dot name. This refers to the current object. So you can access the fields and methods of the current object by using this in Java. That is similar to, say, self in Python. Okay. We are also adding two other methods, run and speak. These are silly methods for now. We are simply printing that it runs with the number of legs, and in the speak method we are saying makes a peculiar sound. Let me also talk about the system.out.println here. Although in Android we are quite likely to not use it at all. System is a package inbuilt in Java. Inside it you have out, and on that out you have the method println, which prints whatever you pass it on a new line on the console. Then there is this plus operator, which is connecting runs with the this.numLegs, and then further with legs. So plus is a concatenation operator on strings. It puts together these three elements and creates a string, which is passed to println and which will be printed out. All right, before moving to the next slide, let me briefly talk about naming conventions in Java. Classes are usually named starting with an uppercase, like the capital A in animal here. Fields and methods usually start with lowercase, like a name or numLegs or run or speak in this example. Sometimes you'll find people using names like M name with M lowercase and N capital case for the fields, and M there indicates member of the class, which is another name for field. That is a choice essentially. I think here throughout these slides I have not used the M prefix, but in many of the Android examples I will be using the M prefix. Irrespective of that, Java follows a camel case convention. Now, once again, all of these are conventions. If you write a class with lowercase a animal, compiler won't have any problem. Java compiler won't have any problem. But these are just conventions that are used almost universally. Of course, there will be some exceptions, but something to know about. There can also be constants, and constants usually have a different naming convention. You create them with all uppercase and separate words by underscores instead of camel case. All right. Okay, so we have created a class animal. It has two fields, name and numLegs, a constructor, and then two methods, run and speak. How do you use this class? You can create a dog like this, animal my dog equals new animal, and then with two parameters. First one is the name, let's say Milo, and the second one is the number of legs, let's say 4. That line creates an object by invoking the constructor over here and puts the values of the name Milo and numlegs4 on the fields of that object and returns it, which then we assign to the reference mydog. And then you can call methods on mydog like mydog.run. It should invoke the method here and print that it runs with 4 legs. Okay. So that's a very brief example of reference types in Java. Next, let's talk about some common operators on string and the 4 common primitive types. So string, we have seen the plus, which is the concatenate operator. Booleans, they have logical and relational operators. So logical operators here are not, the exclamation mark, and the double ampersand, and or, which is a double pipe. So these are the logical operators on Booleans. And you can have equals or not equals. Equality comparison like C family languages happens with the double equal to sign. And not equals happens with a exclamation and equals. Characters, you can add to characters because internally they are integers. You can also compare to characters for equality like this. And you can also compare characters for greater than, less than equals, and greater than equals, because characters are basically Unicode values. And you can check whether a character is greater than or less than others, which is useful in dealing with things like sorting alphabetically. All right, the next type is int. Integers again have the arithmetic operators like plus, minus, multiply, divide. Ints also have the remainder operator, which is the percent sign, sometimes called modulus operator. But I think there is a difference between modulus and remainder, especially if you are dealing with negative numbers. So I prefer calling it a remainder operator. Note that the remainder operator is not listed under doubles, although if you use it on doubles, again, the compiler won't complain, but it doesn't make sense to have remainder on a double division. Okay. Integers like characters, you can compare for equality and greater than, less than, etc. Doubles, I have not listed the equality comparisons, although again, you can use them. But that is because of precision. So, best practices suggest do not use equal signs for comparing doubles because there may be loss of precision. For example, let's try doing something like, 12.0 over 2 and compare it with 6.0. Maybe that's not the great example, but some comparisons like that would not give you the correct answers. Anyway, another place where you should not be using the equality for checking if two values are equal is strings and all the reference types. This is also one of those words of Java where the double equals on strings or in two reference types basically simply compares the address or the reference values of the objects and not the actual object values. So you should be using the dot equals method, which we'll talk about a little later, to do any comparisons of reference types. All right, let's stop here and we'll come back for other things in another video.